Okay. Good morning, children. Today I'll teach you algebraic expressions, their types and their real life applications. So we will learn today what is algebraic expression, basic definitions and their real life applications. Okay. So this presentation discuss algebraic expressions, their types and real world application. Understanding these concepts is crucial for solving real life problems in the field of engineering, science and finance also, and various fields also. So first I will learn what is algebraic expression. So basically algebra is a field of mathematics. It is a branch of mathematics where we will deal with the variables, their basic operations and their types. So algebraic expression is a single term or set of terms. Set of terms means collection of terms. It may be one or more than one. So that are combined using addition, subtraction, multiplication and division. That is basic algebraic operations. So few examples are there. 3x and types are there also based on this. First example is 3x, next one is 2x plus 3y, next one 2 minus 5y square, and like that 2x plus 3y minus 5. This expression that contains two terms, sometimes three terms, sometimes one term. So if an algebraic expression contains only one term, this is called monomial. If it contains two terms, this is called binomial. And if it contains three terms, then it is called trinomial. And more than three terms, then it is called polynomial. So next, so what we have done, algebraic expression is a combination of numbers, variables, number is called coefficient, variables and operators are there. So there are three types, basically monomials, binomials, trinomials and sometimes polynomials. More than three terms we will call it as a polynomials. So if we write it here 5x, only 5x, then it is a monomial. If it is 3y square, then it is a monomial again. And monomial is the simplest form. Okay. So next, binomials. So that means algebraic expression consists of two terms only. If an algebraic expression like x plus 5, 3y minus 2, so there are two terms in all. So two terms in all, that means it is a binomial. And if it is more than two terms, then it is called trinomial. But I have written here perfect square trinomial. Perfect square trinomial, why? Because if we take x plus 2 as a binomial and if we multiply x plus 2 by x plus 2, that is binomial into binomial, then you will get trinomial. So next, how to multiply? Now first you have to multiply x into x. Then you will get x square. X into then 2, then you will get 2x again. Next 2 into x, 2x, and 2 into 2, that is plus 4. And here 2x and 2x are like terms. Like terms mean variables, the power of variables same, coefficient may be different. So I will discuss it later also. So x square, 2x plus 2x plus 4, that is x square plus 4x plus 4. So this is there, this is an algebraic expression, it contains three terms. So it is a trinomial. But how you get it? Now by squaring binomial. So it is a perfect square trinomial. Next, so basically more than two terms, trinomial, more than three terms, we call it as a polynomial. Okay, next we move on to the like terms and unlike terms. As I told you earlier, like terms means they have same variable or power of variable is same, but the coefficient may be different. For unlike terms, sometimes variables are different, sometimes powers are different. If we consider 2x plus 19x, this is like terms because here the variable is x, coefficient may be different, no issue. If we write it at 4w minus 10w, this is also like terms. Next 14.2r minus 12r, this is also like terms. And if we write 2x plus 19a or 9a, this is unlike terms. Why? Because here the variables are different. If we write it here 4w minus 10w square, then this is unlike term because here the powers are different. Next 12r minus 12a, variables are different. 32a square plus 9a cube, These are unlike terms. Why? Because the exponents are different. 3y, 8y plus 5, one term is constant and another term has a variable. So these are unlike terms. Next question is why we learn this thing? Why we have to learn like terms and unlike terms? Because if we do basic operation, that is addition and subtraction, this concept is very important. Because we can add only like terms, we can subtract only like terms. Unlike terms we can't add, unlike terms we can't subtract. Unlike terms we can multiply, we can divide. But unlike terms we can't add, we can't subtract. Is it clear to you? Okay. So next, these are the basic addition and subtraction, basic rule, addition and subtraction. How to do addition and subtraction for algebraic expression. Let me take one example, 2x plus 3y minus 5x plus 2y. Here 2x minus 5x, I will take the like terms first. I will combine the like terms, 2x and minus 5x and 3y and 2y. After that, what we have to do? We have to do the basic operations on constants or numerals or coefficients. Because here y is a variable. Why variable? Because value varies. And 3 is the coefficient of it, and 2 is for 2y, for this term 2 is the coefficient of it. So these are like terms, 3y and 2y, so we can add here. So 3y plus 2y, 3 plus 2 is 5, so this is 5y, and 2 minus 5 is minus 3, so this is minus 3x. Next you have this question. There are two questions in all. You can try and see the question and tell me the answer. So what will be the answer? The first one is 4x plus 7y minus 5z, and next one 3x minus 8y plus 7z. What you have to do? You have to arrange the like terms. After that you have to do the basic operations. So here 4x plus 3x, and your answer will be 4 plus 3, 7x. And similarly 7y minus 8y. What will be the answer? Minus 1. Next one minus 5z and plus 7z. So minus 5 plus 7, no, 7 minus 5 plus 2z. Similarly, there is a decimal expansion also, 5.66 plus 7.08y minus 4.8x plus 4.5y. How to do? Again, we will arrange the like terms and we will do the basic operations on it. So if we arrange, this is 5.6x minus 4.8x. Yes or no? So what will be the answer? 0.8x. And similarly 7.8y plus 4.5y. What will be the answer? 12.3y. Very good. So this is the basic operations, addition and subtraction, how to do in between like terms. These are the rule. Okay. Next we move on to the multiplication. So how to do multiplication? This is a geometric proof, and we can do this, we can apply it in the algebraic expression also. See, if we take, I will take this side as a, this side as b, this side as a, and this side as b. So that means it is a square. You can check, this side is, the total length of this side is a plus b, and this total length will be a plus b. Yes or no? We know that area of a square is side into side. So the area of the square will be a plus b into a plus b, or a plus b square, or a plus b whole square, like that. So a plus b whole square, I want to find a plus b whole square. What will be the result of a plus b whole square? Check. I will break this in that way. I will make 4 parts of it. See, here it is, this length is a, this length is a. So area of this portion will be a square only. Yes, you can check. This portion only a square. Yes or no? Yes. And this length is a, this length is b. So area of rectangle will be AB. Now this is b, this is a, so it will be again AB. This is b and this is b, so it will be b square. So if we add all these, then a square plus ab plus ab plus b square, what it becomes? A square plus b square. Very good. So this is the thing, a plus b whole square formula. We have proved this result, a plus b whole square equal to a square plus 2b plus b square geometrically. If you do the here algebraic expression is used, as well as we have proved this theory by geometry also. Is it clear? So the remaining things also, if you want to prove this, we can use this diagram also, or algebraic expression only. A into a square, a into b, ab, b into a, ab, or ba. These are commutative. A into b and b into a are equal for real numbers only, and already your syllabus depends on real numbers only. So here AB and BA not different. AB equal to BA for this case. Okay. So using algebraic formulas or a multiplication rule, I will say you can prove this theorem. Okay. So try to write this in your copy. So a plus b whole square. This is a square plus 2ab plus b square, and the remaining things also. It is your homework, or next day I will check that this right hand side will come or not. What you have to do, a minus b whole square means a minus b into a minus b. A square minus a plus b into a minus b, you have to check this is a square minus b square or not. A plus b whole cube means a plus b into a plus b into a plus b. A minus b whole cube, the same thing, a minus b into a minus b into a minus b. You can check, if you multiply a minus b into a minus b into a minus b, this result becomes a cube minus 3a square b plus 3ab square minus b cube. Okay, so write this table on your copy, and you have to prove it. In mathematics, you will get the answer of y. You don't need to memorize these things. You can prove this now because you have learned how to do the multiplication. Write it first. You don't need to prove it now, just write it. Okay. So next one, a plus b whole cube. You can check this is a plus b into a square minus ab plus b square. If you multiply the right hand side, you will get the result as a cube plus b cube. Again, a minus b into a square plus ab plus b square. That means you have to multiply a into the whole portion minus b into the whole portion. That means a into a square plus ab plus b square minus b into a square plus ab plus b square. If you multiply and if you adjust the like terms, if you do the basic operations, addition and subtraction, then you will get the answer that a cube minus b cube. And if a plus b plus c whole square, then you will get a plus b plus c into a plus b plus c. Then you will get the answer a square plus b square plus a square plus 2ab plus 2bc plus 2ca. I will not prove this today. This is your homework. You have to try. If you can't do, then I will help you to do it. Okay. Next. This is some applications of it. So whatever you have learned, I have done basic addition, subtraction and multiplication also. So why we learn this thing? Because algebraic expression have numerous real world applications, where in science, in engineering, in finance, and in other branches also. Because if based on variables, if you want to deal with real life situation, we have to take some variables, and we have to sometimes add these variables. Sometimes we have to subtract. Sometimes we have to multiply. Sometimes we have to divide. So they are used in field of like economics, engineering, science to model relationships. If you want to model the real life scenario, you have to use the variables and basic operations also. In finance, algebraic expressions help in calculating interest rate, because there are so many interest rates. So if you want to calculate what will be the average, what will be the mean, what will be the median, mode like things, you have to use these algebraic expressions. And loan payments, investing growths and investment growths, everything depends on variables. You have to take some variables, not one, more than one, maybe more than two or more than three. So basic operations are used there. Okay. In engineering field also, engineers utilize algebraic expression to design structure and analyze force, optimize performance, whose performance is better, performance is upgrowing or not. We will check using algebraic expression. That means using the help of variables. Value varies, so that means we can take it as a real life applications. Next, algebra in science also, where in science scientific laws, analyzing data, predict experimental outcomes. If you are doing any experiment, there must be so many variables, and there may be one or more than one outcomes. But based on these variables, when you are doing the calculations, you will get the outcomes. So there are also some algebraic expression are used. Okay. Next, so this is the conclusion part for this class. So in conclusion, understanding algebraic expression is essential for academic purpose only, also in some uses in real life scenario. In professional fields, in finance, engineering, science demonstrated their significance in real world also. So solving real world problems, we have to require this, we have to use this. Yes or no? Okay. So now you can ask me what we have done today. An algebraic expression definition, some basic operations, addition, subtraction, and multiplication. I have skipped division, but next day I will do that. And what you have learned today? Now addition, subtraction, and multiplication. Yes or no? And there are some real life application in which field we can use this. These are the uses. Okay. So if you have any question, you can ask me now. Today up to this, but if you have any question, you can ask me. After that, I will give you some question to do. Do you have any question? Yes.
I can't understand.
You can understand? Constants. Constant means there is no variable. So if I write it here, let me write this. See, let me take this expression, x square plus 4x plus 4. Yes or no? This is an algebraic expression. Here the power of x is 2, that means x into x is there. Here 4 into x, these are coefficient. This term is 4x and the coefficient is 4. The term contains variable. Yes or no? But the 4, there is no variables. This is called constant. If there is no variable, this is called constant. Okay, sit down. Anyone more? Yes. Coefficient again. Coefficient means there are 3 terms. Yes or no? X square plus 4x plus 4. If you check this term, x square only. So I can write x square as 1 into x square. So 1 into x square. Here it is, the term is 4x. So x, in front of x, there is a numeral coefficient. Yes or no? This is 4. This is called coefficient. If you take the term 4x, then the coefficient of x is 4. If you take the term x square, then the coefficient of x square is 1. Okay? Sit down. Anyone? Yes.
I didn't understand the meaning of the word term.
Term means this is the collection of variables as well as some numerals. Suppose 2x, 4x, 7x square, 5x square, 2.6x. These are terms. This collection of, actually what we have learned, that algebraic expression, see, algebraic expression is a single term. That means if you write any term here, 3x or 2x plus 3y, that 3x is called a term, 3y is called a term, 2x is also a term, 2 minus 5y square is also a term. So these are terms. Okay? Okay. Anyone more? Sit down. No. So okay, then I'll give you this question. Let me give you a few questions. Now try to solve this. Suppose you have this expression. It is not running. Now tell me, it is a monomial, binomial or trinomial? So now if I write it here, Now it is binomial or no, it is monomial because 3 by 7x plus 5x, we can add this. Yes or no? So then it becomes, what will be? 7 5 is 35 plus 3, 38 by 7x. So now this is monomial. It seems like binomial, but it is a monomial. Yes or no? So you have to solve these questions. After that, you will get the appropriate answer. Yes or no? This is trinomial. There is no problem. Trinomial. Okay. So now, if I write it here, 3x plus 5y minus 7x. So now, what will be the answer? Because it is minus 4x minus 4x plus 5y. So it is binary. Very good. Okay. Up to this, say it out? No. So next, if I write it now, 3x square y plus 5x square y minus x square y. What will be the answer? Monomial. But how to do? What is the answer? What is the simplest? Yes. So this is 3 plus 5, 8x square y minus x square y. So it is. Yes. So because like terms can add, but unlike terms can add, of course you can't subtract. Suppose you have this expression like that. Suppose you have this 3x plus 5y minus 2x. So what will be the answer?
X plus 5.
Yes. So this is x plus. This is binomial also. But see, this is the simplest form. You can't add x plus 5y because x and 5y are unlike terms. Yes, very good. Next, we will move on to the multiplication. A. Suppose you have to find hundreds 1 square. How can I do that? Without any basic multiplication, we can do that. What is that? Now, this thing can be written as 100 plus 1 whole square. Yes or no? 101 can be written as 100 plus 1 whole square. We know that a plus b whole square, already we have proved today, a square plus 2ab plus b square. So I will apply it here. So this is 100 square a square plus 2 into 100 into 1. So a square plus 2ab plus b square. This 1 square. Yes or no?
Yes.
So 100 square will be 1. 2 square will be 4. So 4 zeros will come plus 200 plus 1. Yes or no? So your answer will be 10.
10,200.
Okay, so this is the answer. Yes or no? So similarly, if I try to find 99 square, give me one pin. This is not working. So this 9, you have to find now 99 square. How can you do that? 100 minus 1 whole square. So now a minus b whole square formula I will use. So this is a square, that is 100 square, minus 2 into 100, that is 2 into a into b, plus b square. So this is same again, 2 square 40 minus 200 plus 1. So what will be the answer? Try to calculate.
8,000.
No. 10,000 minus 200. Do it.
9,801.
9,000. 9,000. Yes, very good. So this is the answer. Okay, so after this, so what we have learned today? Now, what is an algebraic expression? Now, it is a term or collection of terms contains some numbers with some variables, and after that we have learned like terms, unlike terms. After that we have learned some basic operations on it, addition and subtraction with multiplication. We have learned these formulas also, a plus b whole square equal to a square plus 2ab plus b square. We have learned this. We can prove this by multiplication rule as well as geometrical proof also, by using the concept of area of rectangle and area of square also. And after that we have learned a plus b whole cube formula, a minus b whole square formula, a cube minus b cube, a cube plus b cube. All these formulas we have learned today. And after that we got these applications also, how to do this.